Okay, let us talk Ravindra to me, and others can be in mute condition. Whenever if you have a doubt, you can ask me. So we'll try to clarify. Over, no?
Yes, sir.
Yes,
Yeah.
sir. Completed, sir.
Yeah. So try to understand the problem clearly. So here there are two engines will be there. A and B are connected in series. So let us take one engine A and one engine B. They are connected in the series. So in the sense, no. Let us take this will be one reservoir. So this is one reservoir that is at T1. This is at T1. So what is the temperature here? What is the T1 temperature?
1000 kilos. Joules.
1000
Kilos. Kelvin.
1000 Kelvin will be there.
1000 Kelvin, sir.
Yeah, 1000 Kelvin will be there.
1000 kilo Kelvin, sir.
Yeah, Ravindra, you can speak. Others can be in mute condition because if everybody speak now, I have to listen 40 voices. I request Ravindra and CR. No, they can be in mute condition. Others, no, they will be in unmute condition. Others will be in mute condition. So here T1 is given. That is a source for what is that? Engine A. So engine A will be taking heat from the T1 and producing work W1 and producing work WA. Next one is it is rejected. It is rejected. So here it is taking, that is Q1. This is Q1. Next one is here it is rejected to the at T2. It is rejected at T2 to the heat engine B. Is it okay?
No, okay, sir.
Yeah, it suddenly disappeared and once again coming in. No reason. Okay, let us go for screen sharing. Okay, what is the screen sharing? Once again. So here it is there. Now it is the heat will be rejected to here engine B will be there. It is called as B engine, heat engine B, which is also taking heat from this one, rejected heat here. If you call it as Q2, it is called it as Q2. So here also it will be Q2 only. Here also it will be Q2 only. So then it will be rejecting heat to the lowest temperature Q3. What is the temperature? T3. What is T3? T3 is given. T3 is given. Lowest temperature now is given. What is the T3 value?
Sir, 100 Kelvin, sir. 100 Kelvin, sir. 100 Kelvin, sir.
100 Kelvin is given. 100 Kelvin is given. Next thing is, it is also producing certain amount of work. It is also producing certain amount of work. It is also producing certain amount of work. So I request all of you draw this diagram. Here heat engine C and B will be connected in series. A engine will be taking the heat at a source 1000 Kelvin, and rejecting heat engine B will be rejecting to the sink at 100 Kelvin. So in such case, no, they're asked to find if the efficiencies are equal, no, they're asked to find heat rejected by the engine B, that is Q3. Next one is the temperature at which heat is rejected by the engine A, that is T2. Next one is work done also they're asked to find for the case 1. Okay.
Yes, sir.
Request all of you draw all of you draw this one. No? Over, no? So draw, have you completed this diagram? Huh?
Yes, sir.
Yeah.
Yes,
Let
sir.
us take a condition will be here. The condition is, what is the condition they have given here? The condition here is efficiencies are
Same, sir.
efficiencies are equal. That is, the efficiency of A is equal to efficiency of B. Efficiency of A is equal to efficiency of B. So what is the formula for efficiency of A? Carnot efficiency will be, anybody? 1 minus T2 by
T1.
T1
1 minus T2 by T1, sir.
is equal to, this will be 1 minus T3 by
T2.
T2. So like this you will get. Now we will substitute the values. Minus 1 will be get cancelled. 1 will be get cancelled, and the minus will become plus. T2 value we need to find. T2 we need to find. If you cross multiply the things now, you will get T2 square is equal to T1 T3, or T2 is equal to root of what is that you get
T1,
root of
T3.
T1 T3, root of T1 T3, like so. Like this you will get that. It will be root of 1000 into 100, no, 1000 into 100. What is the value of root of 1000 into 100? Anybody? What is the value of T2 now? You can take the calculator and tell me this value, my T2 value.
Sir,
316.22, sir.
6.22,
31
6.22.
6.22 Kelvin. So like this we can find T2 value. So once we got T2 value, we'll go to the other values. What is asked to find, anybody?
Q2, sir.
Huh? He asked to find
Heat rejected by engine B, sir.
heat rejected by engine B. Heat
Q3,
rejected
sir.
by engine B means Q3 we need to find. Q3 we need to calculate. And what is second condition asked to find? The second condition asked to find is
heat is rejected. The temperature at which heat is rejected by engine
temperature
A.
at which heat is rejected by the engine A. Temperature at which heat is rejected by engine A will be T2. Am I right? Temperature at which heat is rejected by the engine A will be T2. So that is 316.22 Kelvin, which is already calculated. Next one is third point is he asked to find is work done during the process by engines A and B. He asked to find what is the work done WA and what is the work done WB also he asked to find. So you need to find all these things. Let us start with the engine 1. Let us find Q2 value. Can you find Q2 value? Can you find Q2 value? So Q2 value will be calculated as, absolute thermodynamic scale, no? What is that? Q2 by Q1, Q2 by T2 is equal to, am I right? Q1 by T1. So by using this expression, we can find Q2 value. We can find Q2 value. Q2 will becomes now T2 by T1. T2 by T1 into Q1 will be, Q1 is given now. In the problem,
Q1, yes, sir.
Q1 is given. In the problem,
1680
Q1 is
kilojoules.
given. The value of Q1 will be 1680 is given. So you substitute here. T2 value already just now we have calculated. T2 is, what is it? 316.22 divided by T1 is 1000. T1 is 1000 multiplied by, what is that value? Q1 is, what is the value?
1680, sir.
1680. So you substitute, you can get, that is the heat rejected by the engine A. That is Q2 will be
531.24.
331.
531, sir. 531.
531.24
24.
Kelvin. So I request all of you cross check the value. I hope the value will be same. Okay.
Yes, sir. Kilojoules.
Yeah, kilojoules. Sorry, kilojoules it is. Thank you, ma'am. So by using this relation, we calculate. Similarly, if you consider the engine B, the expression will becomes Q2 by T2 will be equal to, Q2 by T2 is equal to, you can find Q3 by T3. So from this expression, we can find the unknown value, that is Q3 is equal to, we can write T3 by T2 into that Q2 value just now we have calculated. So T3 is already 100 now.
Yes, sir.
T3 is 100 divided by, this is T2 is 316.22 into the Q2 value is just now we have calculated 531.24. So finally you will get
167.99, sir.
Q3 is
167.99, sir.
167.
Nearly 168, sir.
167.99, no?
Yes, sir.
Kilojoules will be there. You cross check the value. So this is the value you asked to find. Q3 value you asked to find. So Q3 will becomes 167.99. So Q3 is asked to find. So the Q3 value will be 16.99 kilojoules, something like that you will get. So 167.99. 167.9 is the answer. 167. This is the answer for Q3. Now we are going for WA. Once we know all heats, we can easily find WA. WA is equal to, what is the expression? We'll get Q1 minus Q2. Similarly, work done by B is equal to Q2 minus Q3. So like this, we can find the work done by the engine A and work done by the engine B. So here QA is given 1680 minus Q2 is how much?
531.26.
531 point.
531, sir.
531.
26.
0.2624 or something, 26 will be there. You substitute there,
Yes, sir.
you will get the value of work done. Similarly, WB is equal to 531.24 minus 167.99. You substitute it and you tell me the value. You tell me the values.
Sir, WA, sir. WA, sir.
WA is equal to how much?
1148.74.
1148.74
48.74, sir.
kilojoules will be there.
And Q2.
And this value
Yes,
is
sir. Q2.
363.25, sir.
363.25 kilojoules will be there. So like this, like this, we are doing all these calculations. This is the case one. When efficiencies are equal. When efficiencies are equal, we are finding like this. Okay.
Yes, sir.
This is case one. This is case one. What is the second case will be? The second
Works are
case
equal,
is,
sir.
this one. The
Works are
second
equal,
case
sir.
is if the engines A and B deliver equal amount of work. This is the case. The engine A and B will be delivered equal amount of work. Then the amount of heat taken by the engine B is you need to find. And also you need to find efficiencies of A and B also you need to calculate. So if you remember, in the last class we have discussed about case 2 when efficiencies are equal. So when efficiencies are equal means WA is equal to WB. WA is equal to WB. And we proved that T2 will be equal to root of T1, T3. Like this we did no last class. You remember it?
Yes, sir.
Like this no. Otherwise, so I'm sorry, it's not like that. It will be the equal. No, this is not correct actually. I will delete this one. So when works are equal, when works are equal, we calculated the intermediate temperature will be T2 will be T1 plus T3 by 2. Like that we have proved actually, I think so. Do you remember? You refer the previous notes, ma? When efficiencies are equal, when work done is equal, then the temperature will be middle temperature will be T1 plus T3 by 2. Anybody having notes, you can refer it. You will have this expression. Ravindra,
Sir.
we have the notes, previous notes.
Yes, sir.
So in that we have proved like this. Intermediate temperature will be it will be equal to like this. We have proved.
Yes, sir. Okay.
If you can cross verify. Is there?
Yes, sir.
No, because
That means what? Q1 minus Q2, no, sir. Work for engine A.
Q1 minus Q2.
You work for engine B, Q2 minus Q3.
Q1 minus Q2 is equal to.
We can equate that, no, sir.
This one will be. This will be Q2 minus Q3 will be there.
Yes, sir.
So you will get 2Q21. 2Q2 is equal to Q1 plus Q3 will be there. So Q2 will becomes Q2 is equal to, you can write Q1 plus
Q3 by 2.
Like this you can write. This for heats, no. Coming to the efficiencies, no. For example, if you divide this one with Q1, first expression with Q1, if you divide with Q1, no, it will becomes
Efficiency.
or you divide with Q2 first expression, you will get Q1 by Q2 Q1 by Q2, am I right? Minus 1 is equal to divide the second expression,
And Q2.
divide this expression by Q2, then you will get 1 minus
Q3 by Q2.
Q3 by Q2, Q3 by Q2, Q3 by Q2. So here minus will be get kind of minus 1 minus 1, 1 will, am I right? No, it will not be get cancelled, sorry. So here you will get Q1 by Q1 by Q2 will be Q1 by T1 is not T1 by T2 will get T1 by T2 minus 1 is equal to, in place of Q3 by Q2 we can write because Q3 by T3 is equal to Q3 by T3 is equal to Q2 by T2. So based on that you will get Q3 by Q2 is equal to 1 minus T3 by T2, 1 minus T3 by T2. So here also you will get, if you take LCM this side you will get T1 minus T2, and this side you will get T2 minus T3 LCM, and LCM will be get cancelled here, T2 here also T2 here. So this thing will be get cancelled. So finally we'll have we can have T1 minus T2. The total expression will be converted into temperatures. T1 minus T2 is equal to T2 minus T3. So send T2 this side, this T2 this side, and T3 that side. No, we'll have T2 plus T2 will be 2T2. So this is T1. If it is goes that side, we'll get plus 2, 3 will be there. So finally, we'll write T2 is equal to T1 plus T3 by 2. Like this, we can write intermediate temperature. Now it is understood, no, Ravinder?
Yes, sir.
Bharadwaj, here. So now, okay.
Okay, sir.
Now find, all of you find T2 value when works are equal. T2 is equal, this will be 1000. This will be 100 by 2. So it will be 1100 by 2. So the value will be 550 Kelvin. 550 Kelvin. So when works are equal, the intermediate temperature will become 550 Kelvin. So what he asked to find? He asked to find amount of heat taken by the engine B. Amount of heat taken by the engine B will be, the amount of heat taken by the engine will be Q2, because this Q2 will be rejected by the engine A, and that will be taken by engine B. Okay. So now we need to find Q2. So for finding Q2, the expression will be absolute thermodynamic scale, that is Q1 by, same thing only we are using, Q1 by T1 is equal to Q2 by T2. This is absolute thermodynamic. From this you will get the unknown value Q2 is equal to that is T2 by T1 into Q1. So T2 value we have calculated 550 by 1000 into Q1 is 1650, no, 1850.
1680, sir.
1680. So substitute here. So you will get 1680. You will get the
924, sir.
Q2 how much?
924 kilojoules.
924 kilojoules will be getting. This will be the answer he asked to find. What is the next question he asked to find?
Efficiency of engine A and engine B, sir.
So efficiency of engine A and engine B, you can do this one. Efficiency of engine A is equal to 1 minus, all the temperatures you can find. 1 minus T2 by T1. Substitute this, you will get 1 minus T2 is just now we have calculated 550 by 1000. So you will get the efficiency. Similarly, efficiency of B is equal to 1 minus T2 by, T3 by T2. Yeah, that is equal to 1 minus T3 value is 100, no, 100 by 515. So you will get the efficiencies will be. What is the efficiency A and efficiency B? No?
Sir, efficiency A 0.45, sir.
0.45 or 45%. This thing will be
81%.
81,
Yes, sir. 0.81.
Yes, sir.
0.
81.
No, it cannot be 0.8, 100. Okay, 400. Okay, 0.8. 8?
Yes, sir. 81, sir.
81. So the efficiency will be around 81%. So like this, we are doing the problem. I hope you understand this problem, no?
Yes, sir.
Yes, sir.
Yeah. Now let us go to the theory part of entropy. I will share one more slide to you. The screen will be